Hello everyone, welcome to Code Tab Management. So we will discuss one scenario today. I think that will be helpful for your upcoming interviews or your project related activities. So just imagine the scenario like you are using your banking application on your mobile phone, and unfortunately one day your phone gets stolen. So like what you will do after that? You will immediately log in from your laptop, right? And you will click like log out from all the devices. So now here is an interesting interview questions. Like if JWT is stateless and stored on the client, so how can the server immediately invalidate that token before it expires? Right. So if the token is still valid for another 30 minutes or 60 minutes, so does the hacker still get access? So this is one of the most frequently asked system design and Spring Boot related interview question for Java developers like with 3 to 10 years of experience. So in today's video, we will understand like why JWT creates this problem, why normal logout doesn't work, then some production grade solutions. Then which solution companies like Google, Netflix, Amazon, banking applications use? Then how to implement it in Spring Boot. Okay. So first understand like what is the JWT? Maybe you know, maybe not. And in Spring whole playlist, like Spring Boot playlist, I have covered some Spring security related videos like OAuth, JWT, OIDC, like OpenID Connect. So those things you can see from the playlist Spring Boot, and from there you also can learn. But today specifically this scenario related problem we will focus. So JWT is basically the JSON Web Token. So whenever a user logs in successfully, the authentication server creates a token. So that token contains information like user ID, username, roles, some expiration time, and the token is digitally signed using a secret key. So now the client stores this token is usually like in memory, cookies, or local storage. So whenever an API request is made, then the token is sent in the authorization header. Okay. And the server simply verifies three things like is the signature valid, has the token expired, and and are the claims correct or not. So if everything matches, then the request is accepted. So the server never stores this JWT. So that's why JWT is called the stateless authentication, right? So that's why JWT is called the stateless authentication. So this gives the excellent scalability because the server doesn't need to maintain any session information, right? So no storage or something related to that token. But this also introduce a major challenge, and we need to fix that problem. So what the problem is? So just let's consider a real world example. Suppose one person logs into his banking application, right? Now the application generates a JWT valid for 1 hour. After that, like after 1 hour, again new JWT token will be created, but within that hour, only that JWT token is valid. So after 10 minutes, suppose that person loses his phone. So he immediately opens his laptop and clicks like log out from all devices. Now ask yourself, like where is that JWT stored? It is already inside the stolen phone. Can the server simply delete it? No. because the server never stored it. So the JWT is completely self-contained. So the server cannot simply delete it. As long as the signature is valid, expiration has not happened, so the stolen token can still access APIs. Okay. So this is exactly why simply using JWT is not enough for enterprise application. Now we will show you like why JWT stateless that I have told you, right? Now the solution one, the token versioning. So this is my favorite solution and one of the most scalable approaches as well. So let's understand it step by step. So suppose the user table has a new column called token version. So initially, suppose one user ABC and token version is 1. Okay. Now, while generating the JWT, we include the user ID and token version as 1. So whenever an authenticated request comes, so Spring Security validates the JWT version versus database version, right? So if both are equal, request is accepted. Now imagine that ABC people, like that person, clicks log out from all devices instead of deleting JWT. So we simply update the database, right? So now token version will become as 2. The old JWT still contains the version 1. So when the next request arrives, then database says version as 2, but JWT says version as 1. So that will be one mismatch. So then request got rejected. Okay. So instant lockout will be happened. So you understand the process, right? So this approach is extremely scalable because only one integer changes. That in the database, we are changing the version according to the case. Like at first login thing was there. Then when log out, then the version will be updated. But in the stolen phone, the JWT version was 1. Like that version was 1. But in the database now it is 2. Now version mismatch happened, request will be rejected, instant logout. So that's why it is extremely scalable because only one integer changes. So no blacklist is required, no memory overhead. Many enterprise systems basically use this technique. So we need to just maintain the token version in user table. Okay. And we need to also include it in the JWT. After that, we will compare the DB value on every request, then increment the version on logout all, and old tokens fail instantly. Now, the second option is refresh token. So this is probably the most common implementation in modern applications. So instead of issuing one long-lived JWT, companies basically generates two tokens. One is access token, another is refresh token. So access token lives for only 5 to 15 minutes and refresh token lives for 30 days. So access token is used for API calls and refresh token is used to generate new access tokens. So now what happens during logout? The application deletes every refresh token stored in the database. Now, even if somebody has the access token, it will expire in a few minutes. After expiry, they need a refresh token, but it has already been revoked. So therefore, no new access token can be generated, and that basically reduces the attack window. Understood? Now, The third case is like blacklisting. Okay. So here what will be happen, like another approach is maintaining a blacklist. So every JWT has a unique identifier called JTI, that is the JWT ID. So when the user logs out, the server stores that JTI, like the JWT ID, inside a Redis. So during every request, Spring Security basically checks the Redis. If the JTI exists, then reject the request immediately. Okay. As during the logout, actually, the server stores that JTI inside Redis. So whenever in the request, like whenever logout happens, then JTI will be created, right, in the cache or Redis. So whenever that JTI exists, it will reject the request immediately. What will be the advantage for that? It will be like immediate invalidation. But what is the disadvantage of it? Like Redis lookup happens for every request. So extra memory is needed for that. So therefore, blacklist is usually used only for high risk scenarios like password reset or compromised accounts or security incidents like that. Okay. Now the solution for is like session tracking. So many applications maintains an active session table. So it stores like device name, browser, IP address, login time, refresh token, status. So whenever the user clicks log out from all devices, so every session becomes inactive. The next refresh attempt automatically fails. So this also allows the users to see like currently logged in devices inside their profile settings, right? Exactly like Gmail or Facebook. So that's the case. Now, the production architecture. So, ho- just understand like how the companies actually implement the authentication. So, users basically logs in, authentication service generates the access token, refresh token, then access token validity will be there, suppose 10 minutes, refresh token validity will be there like 30 days. Then refresh token is stored inside the database. Now, token version is stored inside a user table, and Redis stores blacklisted tokens only when necessary. So every API request passes through Spring Security filter. The filter basically validates the signature, expiration, token version, blacklist. Only then is access granted. So when the user clicks like logout from all devices, the application performs three operations. First, delete all refresh tokens. Second, increase the token version. And third, optionally, blacklist the current access token. So now every old token becomes useless. Okay. So the flow will be like client, then API gateway, then auth service, then JWT validation, then user DB or Redis. Now, how we can implement it with the help of Spring Boot? So if you are implementing this in Spring Boot, so you need to create a JWT authentication filter first. Then you need to extract the JWT. You need to validate the signature, extract the user ID. You need to fetch like user details from the database. After that, you need to compare like token versions. You have to check the Redis blacklist if enabled. After that, you need to like allow or reject the request during logout all devices. Okay. So uh, during like logout all the when you like when the person like will do the logout from all devices in there are some I have told about like token versioning. So you need to update the token version, and after that like you need to delete the refresh tokens, and after that you need to return success response. So it will be simple, secure, scalable. So again, I'm just repeating the steps. So you first of all you need to use the Spring Security filter. Suppose one is like JWT or auth token swap filter is one filter. So it basically extends the one request per filter like that. After that, it validates the signature, expiry, token version, then repositories for refresh tokens, then Redis template for the blacklist, and increment the token version one logout. Now, if you will compare the things, so token versioning is scalable. Revocation is industry standard. That's why, like, most of the microservice applications basically use the refresh token generations and all. And blacklist is immediate, but costly operation is there, as we are using the Redis there, and if for every request we need to fetch the Redis and all. So there some memory utilizations will be there. So it will be costly operation. So response time will be high. Okay, so there's conditions are there. So blacklist is immediate but costly. Session tracking is like for device management. So uh, as a one liner, you can give the answer like JWT cannot invalidate itself because it is stateless. Production systems combine short-lived access tokens, revocable refresh tokens, token versioning, and optionally Redis blacklist to immediately log users out across all devices. So, like, JWT itself cannot be invalidated because it is stateless. The server never stores it. And production applications solve this problem using short-lived access tokens, refresh token in revocation, token versioning, and session tracking, and also like Redis blacklisting for critical cases. So if someone asks you this question during an interview, you need to tell it like that. Okay. So now I will tell, like, if you found this video useful, just please like the video, subscribe my channel, share it with your developer friends, and don't forget to press the bell icon, because every week basically I upload some Java, Spring Boot, microservice, system design, or AI engineering related contents to help you like crack top companies, or like to like expand your knowledge base. Okay, so thank you for watching. uh, See you in the next video. Still then, stay tuned.